This is the PCB of Midea Mini Split Air Conditioner DC Inverter Indoor model, and today we are going to repair it. Now, I'll explain to you what the problem is with this PCB. While repairing this board in the previous video, I fixed its broken traces and replaced several components, yet the board still didn't work. When I re-inspected the circuit board, I found that its chopper was burned out. Now let me explain how I figured out it was burned, because at first glance, it didn't look damaged at all. So, if the bottom winding is burned, it won't be easily detectable. However, if the top winding is burned, which often happens due to its design, it can be identified. This is because the mechanism consists of two windings, one at the top and one at the bottom. The top winding is on the high side. It also burns out. So here I will show you how I tested it. I have a microscope installed here, and a screen is also attached to the microscope. So look here, when I checked it up close, you can see very clearly that all the insulation at the top has gathered together. Apart from this, if it wasn't damaged, you would see that the top insulation usually looks completely fresh. This makes it easy to identify whether the PCB is faulty or in good condition. Here, if you observe, you can see that this point has also gathered together. Due to this gathering, the high voltages often cause the insulation inside to accumulate. If it turns completely black, then it becomes very clear that it is damaged. Look, if you observe this side, you can see that it is burned. This way, you can easily check and identify such issues. This side is the high side, and the other side is the low side. You should know the difference between these two. So most of the PCBs, whether it's a 1.5 ton, 1 ton, or even 3 ton inverter, the choppers usually give readings around 3, 4, or 5 ohms. If we get a reading of 4, 5, or even 6 ohms, then it means everything is perfectly fine. So now I'll check one of the points. As you can see, it's not showing anything at the moment. Now I'll check the next point. It's showing a reading of 83.2 ohms. This is a very high reading because the wires have become shorted and attached to each other. That's why it's showing such a high reading. And the same is happening at the next point as well. Here, it's not showing any reading, which means this point is internally disconnected. That's why it won't be functioning properly. After this, we will check the low side. Here, you can see that 2 points on the low side are together, and it's showing a reading of 0.3 ohms, which is fine. Now let's check the next point. It shows 0.6 ohms, which is also fine. However, it shouldn't be a short circuit because if it were, it would cause problems. This is how you can check it. But as we can see, most of the issues are on the high side. So this is one test completed. The next test here is a comparison test, as choppers come in many types. The resistance value of each chopper is checked, but each chopper is different from the other and has a different resistance value. Therefore, there is no fixed or permanent method for this. You can only check it using a multimeter and test it physically. Additionally, if you're working permanently with these choppers, you will need to keep track of their resistance values. Each chopper has its own specific resistance value, and you should remember this number for reference when testing them in the future. So first of all, look here. All the points are disconnected from each other. You can see that there is no value at all, which means this part is completely damaged. Now look here. This point is live and working. It's showing a reading of 0.6 ohms. Since the other chopper is completely fine and has been repaired, if you check these points, you should also get a reading of 0.6 ohms. The reading is 0.6 ohms here as well, which confirms that this part is functioning correctly. And now when we are checking the other terminals, it's showing a reading of 6.4 ohms because this chopper has double coils, which is why the reading is higher. Now when we check the next coil, it's showing 3.9 ohms, which is typical for the low side because low sides use thicker wires that have lower resistance. On the other hand, high sides use thinner wires, which have higher resistance. You should note these values for reference. Furthermore, if you have repaired the chopper, make sure to record its number and keep a data sheet. By maintaining this data sheet, you will have an understanding of which chopper it is, its settings, and the values like resistance, ohms, that you are getting. And now, this PCB is completely repaired and it has started working. However, for the sake of guarantee, I have replaced some components in it. If the chopper fails again, or if there's another issue, it could lead to a bigger problem. In addition, there were some faulty components that appeared to be working fine. This is a switching IC and its number is TNY276GN. At first glance, it appeared to be completely fine, and even during testing, it seemed to be working properly. Upon closer inspection, you can clearly see that it has cracked. And look, it was also showing its position as perfectly fine. But when we powered it after repair, it started causing a short circuit. After that, I replaced this IC, and I also replaced the capacitor as a precautionary measure. This way, if there is any hidden issue, it won't cause problems later on. So now I will connect it in series. As you can see, our PCB has started working, but it is currently showing an E5 error. Next, we will provide it with direct electricity and check it again. Now, let's provide it with direct electricity. As you can see, it has started working perfectly. At this point, the PCB is fully repaired. I hope that by following this method of checking and testing PCB components, you will also learn how to repair PCBs. I hope today's video has been very helpful for you. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.